Good evening, everyone. I'm going to do a 12 to 15 minute video going over the severe weather setup for the next 2 days. Today is Tuesday, the 16th of March. This is the storm prediction map for tomorrow. It's very rare that you use a level 4 warning. You see a lot of 1, 2, and 3s, but very few 4s, and I've only seen 5 used once. And they're saying that this might be revised early tomorrow to include a category 5, because this area, and I'll show you on the maps that I want to show you, this area looks set up for bad storms. So northern half of Mississippi, I'm a little bit concerned about tomorrow. Now, the day after tomorrow, on Thursday, this is a level 3 enhanced, and this will be revised again tomorrow too. We'll see how they draw the box out. Now, let's start with the triple R model. This is basically a simulated radar. This is the latest run. It goes out 48 hours, and right now, for example, when this says 4Z, it's really 12 o'clock tonight, because we're 4 hours behind Zulu time if you're on the Eastern time zone, or 5 if you're on the Central time zone. So if you look, I'm going to run this through tomorrow. I'm going to put in the early afternoon. First of all, you'll see in the morning tomorrow there's going to be some rain here that may make the air a little bit more stable here, but you'll see in the afternoon it's going to come back. You see these isolated storms. This is what I'm worried about in the early afternoon. This is around noon central time, with the daylight heating. These storms can become very severe because of the next screen I'll show you. You have lots of Cape, lots of Shear, and these isolated storms can become very strong because they don't have to compete for the Cape or the fuel, because the next storm may be several miles away. Therefore, they're not trying to compete for the fuel source. As you can see, tomorrow afternoon, northern Alabama seems bad, but what's going to happen is tomorrow night you're going to get a line of storms that will also produce severe storms. So this is, let me back it up, and just see how all these storms begin to appear. And these are going to be isolated storms that can produce an EF2 or greater. I'm going to go back and show you one other thing here. This is the tornado threat. And you can see in this hash part, they're saying this is the area where you have a higher chance of EF2 to EF5 storms. And then the wind, this is where you're going to have very high winds in the hash mark, about 65 knots, gusts of 65 knots, that's 75 miles per hour. Hail, this area, they're expecting hail greater than 2 inches. The other areas is the percent chance of getting hail of 1 inch or more. So tomorrow is going to be really bad. Okay, let's keep moving. So if you go back to Mississippi, this area will get some storms around late at night, and that's why I'm worried about these. The storm, or the squall line, will have rain wrap storms that can quickly put down a tornado. And at night you have very little light, and it's going to be all rain wrapped, so it will be hidden, and you won't know it till it's right on top of you. So during the night, these storms will start to go down, but in the morning you'll have the heating of the day. So by early morning, this looks like this will be about 9 o'clock on Friday. This could be, again, a squall line that we're worried. Now, this will be about 11 o'clock. And I'll show you on another model. This looks like this is when the bad storms will hit us. All right, so let's go to the next screen. So this is called surface-based CAPE. Now, what you're trying to look for to have a really strong storm, you need to have about 1,000 CAPE. This is where I'm going to show you the CAPE for tomorrow. And I can show you. See here, you got 3,000 CAPE right there. Up here, you'll have almost 2,000 to 3,000 CAPE. And this is towards tomorrow night. So you can see this area looks bad tomorrow. On Wednesday, you'll have lots of fuel in this area. And then as the sun goes down, the CAPE goes down. But when the sun comes out, you'll get CAPE again. Let me go to early afternoon. You just need about 1,000 CAPE. You'll have 1,000 CAPE here. See, this is enough fuel. So I'm looking at around noon on Thursday, some severe storms in the upstate. The further in the day, the higher the CAPE gets. Okay, next screen. This is called the Helicity, the amount of spin. So this particular, and I'll show you three of the updraft Helicity. It's just trying to predict where the funnel clouds might form. This is a 1 hour window, and you can see where this looks like. Again, this is predicting a path for a potential storm. But you can see here, this is at about 8 p.m. tomorrow night. It shows you, and there's some bad storms here near the Tennessee state line that they're predicting. This could produce a funnel cloud. This is 1 hour blocks. This is 3 hour blocks. So show you the trails 3 hours at a time. What would make more sense to show you the whole run. So this will show you the tracks will stay on there. This does add up all of the potential tracks till the end of the run of the simulation. So what this shows, this is the area where they're producing long track storms. They're predicting super long track storms on this model run. And also it looks like there's going to be some severe storms here that may produce long track storms. And again, these are not anything to sneeze at. Let's go to the next screen. So this one is called the Supercell Compose. That is the tool where it looks at the things you need to produce a supercell. So if you look down here, anything a 3 or higher means there's a good chance you'll have super cells, a rotating storm that can at any time produce a funnel cloud. And so if you have a score of 3 or greater, that's a really great chance. You get really, when you get towards 9 or 10, that means you will have lots of storms in that area. So this is very interesting. This is tonight at right now. This is right now. I'm going to go forward to about early afternoon. I'll move this to about 16. Now this is around noon central time. And this is why I was saying that this is where the supercell score is 10 or greater. That's like bad news. If your score is 3 or 4, that's a good chance of a supercell. See, there's so wide of an area. That's what I'm worried about, is look how big this area. If you don't get them drawing a map that much level 4. And the reason why I'm concerned is because this is the supercell composite. So if you look early tomorrow, this is early tomorrow, you can see you got supercell composites in the teens. that you just don't see very often on a model run. Look at this, 22, 16. So this is showing that all the ingredients are coming together. Now, if you go to early on Thursday, late morning, you got scores, 6, 7, 8. That's not good. Look at that. That's an 11. So what I'm worried about is around 10. This is 10 a.m. This is at 11 a.m. You have a 4. So even in the up state, you got scores near 3 or 4. All right, another thing that's very good to look at where the tornadoes is called the significant tornado parameter, the STP. Anything greater than 1 means there's better than 50-50 chance you'll see a tornado in that area. So you need at least a 1 to have like a 50-50 chance. And you can see, let me move this ahead. So when you get it near a 3 or 4, that's not good. So if you go till tomorrow afternoon, Central Time, you get a good 1 to 2. If you keep going forward, now this is what I'm worried about tomorrow late. Now this would be about 5 p.m. Look at this. This is why I'm worried about here. Let me go backwards 1 hour. So towards the eastern part of Mississippi, you have these scores around 3, 3.5, 4. Let's go forward in time. See here, you got a score of 5 right there. That's very concerning. So this area late tomorrow, I'll be very concerned about. Let's go forward to early on Thursday. Again, you have scores approaching 1 here. If you reach towards the afternoon, looks like the eastern part of the upstate, the Midlands are under the gun. This is noon tomorrow. See, parts of Spartanburg will have a score of 1. Columbia will have scores closer to 2. All right, let's go to the next screen. Now, this is what I was going to say, a large shear event. So this is at the jet stream. This is at like somewhere about, would be about 30,000 feet above the ground. You have wind that is going at nearly 100 knots on this screen. And this is for, let me move it till Thursday, early afternoon. This is around noon. See, you got all this wind. And so that anytime you get a spin up, this will produce a strong wind at the surface, and it can also make a EF2 or greater storm. So I'm looking at this high wind jet. This is called bulk shear. Now this is looking at the bottom 6 kilometers, or the bottom 3.5 miles. So it takes the speed at the ground and compares it to the speed at 6 kilometers above the earth. And anytime you have a difference of 40 knots, that's lots of shear. 60 knots, I get very concerned about. Again, this is early afternoon on Thursday. We got 60 to 80 knots of wind shear. What I'm also concerned is if you go to 1 kilometer above the ground, and this is at noon, you get, again, anything like 30 knots faster than the ground. You get this strong jet going from the southwest, and that can produce lots of hail, lots of wind, and it's an important ingredient to make a tornado. You have to have lots of shear. So you're talking about lower level shear of 40 knots. That's extremely concerning. Whereas if you go to 6 kilometers, you're in the 70, 80 knots. So anything 40 knots or higher, but 60 knots or higher is very concerning. So I'll let you know in a future recording how this goes. Over and out.